Hi guys, welcome after the break. Let's continue with the Mapwork calculations. Now if you look at question 2.1, the first question, calculate the straight line distance in kilometers between the trick beacon 294 in block F1 and the trick beacon 94 in block E1. Now very important over here, they ask for all the calculations. Now there's a couple of tips. Where will you find the trick station 294 in block F1? Now that is an indication that this is on the topographical map of 1 to 50,000. And then I ask you, they want the answer in kilometers. Now if you want your answer in kilometers, you need to times your centimeters with 0.5. Immediately, please remember to read your questions carefully, because this question might have stated to do it on an orthophoto. So be very careful by reading your questions carefully. But let's quickly go and do the calculation. Please note that my calculation, centimeters, is not going to be the same as yours because I've got the map in front of me that I zoom in and out. But I will give you the correct answer. So the question states, calculate the distance straight line from block E1. There's trick beacon 94, as you can see, situated over there, E1 to F1. Now if we quickly look where F1 is over there. So all you need to do is place your ruler between the two areas and you measure your distance and you got 4.8 centimeters. 4.8 centimeters. Now very importantly, because we're working on a topographical map, what's going to be your formula? 0.5. So you times it with 0.5. And let's quickly get our calculator out. 4.8 centimeters times 0.5. And you'll get an answer of 2.4 kilometers. Okay, simple, just like that. Remember your formula. It's going to change when you use an orthophoto map, will change to 0.1. What will happen if the answer was asked in meters? Then that 0.5 will change into 500. Okay. Our next question, determine the present magnetic bearing for the trick station from 290 and block F8 from trick station 292 and block D9. Now before we're going to continue, first of all you need to know what your formula is for magnetic bearing. Magnetic bearing equals magnetic declination plus true bearing. Okay, now first of all let's go and do our magnetic declination. Now where do I get my magnetic declination information from? You go back to your topographical map and you go to the bottom of your map. And here's the information being provided to you. The mean magnetic declination is 25 degrees 29 minutes west. And the map is drawn in July 2001. So this is the date that you are going to use, because we need to calculate the present magnetic declination. Why do we need to calculate magnetic declination? Because we want to arrive at the right correct place, and because of magnetic north. The mean annual change is 9 minutes west, but we need to calculate the annual magnetic declination. So we got our information over there, and let's quickly go and write it down when we do our question. What was the magnetic declination for the Humansdorp map? It was 25 degrees 29 minutes west, and the changed map was taken in 2001. The annual change, annual means yearly, was 9 minutes west. Now, very important, if you can remember, just going to write it in this little block here. West, we add. If it's east, we minus, subtract. In this case, we're going to add because it's going west. Now, we need to calculate the present magnetic declination. This is the year 2017, subtracting 2001. Let's go to our calculator. We don't want to make a mistake. So we say 2017 minus 2001. It gives me 16. Now, every single year, it's changed 9 minutes west. So now we need to calculate, because we want to calculate the present magnetic declination. So 16 times 9 equals, let's go back to our calculator. We don't want to make any mistakes. 16 times 9 equals 144. Keep in mind, this is 144 minutes. Now, how many minutes is in there in 1 degree? I'm just going to write it in a different color pen because I don't want you confused. 1 degree equals 60 minutes. So in this case, 2 degrees will equal 120 minutes. So do you agree with me? The 144 minutes equals 2 degrees and 24 minutes. And because it's moving west, what are we going to do now? We're going to add them together. So 25 degrees, 29 minutes, plus 2 degrees, 24 minutes, equals, okay, 29 plus 24, let's just quickly go and work this out in the calculator. 29 plus 24 equals 53, so it's not more than 60. So it's going to be 27 degrees and 53 minutes. But remember, Draytels, we are not finished, because if you look at our formula, we have just calculated the magnetic declination. Now we still need to go and calculate, determine the true bearing. Now, the question states, determine the magnetic bearing from trig station 290 and F8. Okay, let's just quickly go to our map. Just want to find F8 over here. Okay, this is trig station from 290. I just want to read the question again. Calculate the magnetic bearing of trig 290 and block F8 from. Be very careful. You need to go and have a look where it states from. So this is the one trig beacon, but you need to go and calculate from D9. Now, where is D9? Let's quickly find D9. From trig beacon 292. So from there to there. So you need to calculate the bearing from there, trig beacon 292, to trig beacon 290. Now, what's your simple rules of bearing? Very importantly, you need your protractor. First rule is, remember, draw a north-south line. So you're going to draw a line through trig beacon 292. Your second step, draw a line from where and to. So you're going to draw a line from 292 all the way to trig beacon 290. And then you're going to place your protractor on your north-south line, and you're going to move clockwise. In this case, there's your protractor. You move clockwise, 180 degrees. You turn your protractor also clockwise. And you measure what you see on your, how many degrees on your protractor. In this case, the correct bearing was, the true bearing, the correct answer for the true bearing was 203 degrees. Now, very importantly, once you look at that, what the formula says, you need to add the two. So it's very simple. 203 degrees plus 27 degrees, 53 minutes equals 230 degrees and 53 minutes west. And that will be the correct answer for magnetic bearing. Now, grade 12s, once you're going to see this episode, keep in mind that this date will change to 2018. Okay, thank you. Keep that in mind. The present magnetic declination of the current year that you are in. Okay, let's quickly go and have a look at the next question. Calculate the average gradient. Okay, between trig station 290 and block F8 to the trig station 292 and block D9. Now, first of all, most importantly, know your formula. Gradient equals the height over the distance. Now, immediately you got your first tip as well. Where do you find the trig station 290 and 292? You find it on your 1 to 50,000 map. And we calculate gradient always in meters, so I'm just going to add over there. We know we need to time it for 500. Now let's just quickly go and have a look at our map. Calculate the gradient in F8. (290), there's it. Trig station 290 to the trig station in block D9. 292, as you can see, situated over there. Now, very importantly, matrix, we did discuss this before. Now, a trig station represents altitude. Now, very importantly, the fat italic print is a trig station number. It doesn't represent the height. The 47.3 represents the height. The same with the trig station in block F8. You need to go back there quickly. The 290 is the trig station number. The 26,5 represents the height. Now let's go and do our calculation. We got our height, and you need to calculate the distance between the two of them. From 292 to 290. Just need to find 290 quickly again. Add some block F8. There you go. So how do you calculate the distance between the two? You use a ruler, you place it between the two areas, and you calculate the measurements in centimeters. Keep in mind, my measurement is going to be different to yours because I don't have a scale, because I'm zooming in and out on our map. But I will give you the correct answer in a second. Now, the height, we need to determine the height. And we want to see what's the height difference between the one trig beacon and another trig beacon. And how do we do that? You just subtract. So in this case, 47.3 subtracting 26,5. And then you measure it with your ruler, like I showed you. You measured the distance between the two of them. And the distance that you got between the two of them, let's just quickly have a look at the distance between the two of them, was 5.9 centimeters. Okay, first of all, let's go and see what's the height difference. It's 47.3 subtracting 26.5, and that equals 20.8. And then, because we're working on a topographical map, we take our 5.9 and we times it with 500. $5.9 times 500, that equals 2,915. 2,950. Now keep in mind, we need to get a ratio of 1, and how do we get a ratio by 1? You divide it by the same amount. So 20.8 divided by 20.8, and what's the rule of the math? What you do on the top, you do on the bottom. 20.8. 20.8 divided by 20.8 gives me 1. And then 2,950 divide by 20.8, that gives me 141.8. So that means we have to travel 142 meters before the gradient increases by a meter, and that's quite a gentle gradient. Okay, stay tuned. We're going to continue with some calculations directly after the break.